Chapter 1, Lesson 2, Prime Factorization. Vocabulary. Prime number, a number that only has itself and 1 as a factor. For example, 7, the only factors of 7 are 1 and 7. A composite number is any number that has other factors besides 1 and itself. So, for example, 24. It has all these factors, 1, 2, 3, 4, 6, 8, 12, and 24. All composite numbers can be broken down into their prime factors. For example, 18 is the same as the product of 2 times 3 times 3. 36 is the product of 2 times 2 times 3 times 3. 2 and 3 are all prime numbers, so we've broken down 18 and 36 into their prime factors. There's 2 methods to break down a number into its prime factor. One is with repeated division. So they have an example here using 40. They put 40 into this top box and try and pick out the least prime number they think that can go into 40, and that happens to be 2. 40 divided by 2 then is 20, which is where that 20 comes from. Again, they're trying to find the least prime factor of 20, which again is 2. 20 divided by 2 is 10. And the least prime factor of 10 is 2. 10 divided by 2 is 5. Here they stopped because 5 is a prime number. So now they're breaking it down by taking all these prime numbers on the side and the prime number on the bottom and multiplying by each other. 2 times 2 times 2 times 5 is 40. Here, number 10, they start us off. They're trying to break down 54. They put 54 into this box here and pick 2 as the least prime factor and divide. 54 divided by 2 is 27. 27's least prime factor is 3. So they do 27 divided by 3, and the answer would be 9. 9's least prime factor is also 3, so we divide. And 9 divided by 3 is 3. We stop here again because 3 is a prime number. So now I take all of these prime factors and put it into a multiplication problem. They already gave us the 2, the first 3, and now we're just going to fill in the other ones. Let's try 244. It's an even number, so I know its least prime factor is 2. 244 divided by 2 is 122. Again, 122 is even, so I know I can divide it by 2. 122 divided by 2 is 61. And I can actually stop here because 61 is a prime number. So 244 equals 2 times 2 times 61. The other way to do prime factorization is with a factor tree. This is my preferred method. Just because you don't always have to pick the least prime factor, you can use factors you know. So you're doing the same process. You're starting with your number and you're picking 2 numbers that multiply to be 40. So 2 times 20 is 40. They kept going. This is where I would usually circle it and tell myself I can stop because 2 is a prime number. 20 is not, so you keep going into 2 divided by 10. Again, I would circle that and stop there. And then do 10 into its prime factors of 2 and 5. Whatever numbers I have circled are what is in the multiplication problem. So 54, they already said let's do 2, and that would be 27. 27 can be divided by 3, which is a prime factor, and 9. 9 is not a prime number, so 9 can be split up into 3 and 3. Again, I circle them to show that they're my prime numbers. And I'm just writing those out. 2 times 3 times 3 times 3. Let's do 625. Do it up here. There's a little room. I see that this number ends in 5. So I'm going to break it down simply into 5, which is a prime number. And then 5 times, I'm not sure, so I'm going to use long division. How many times does 5 go into 625? Once. Bring down the 2. 5 goes into 12 2 times. 12 minus 10 is 2. Bring down the 5. 5 goes in the 25 5 times, and that's 25. So 5 times 125 is 625. So I'm only going to keep going on this side now because I circled this. I'm done with it. And it ends in 5, so I know I can break it down more with a 5. This one I know. I know 5 times 25 is 125. So I'm going to keep going, and 5 times 5 is 25. So 625 equals 5 times 5 times 5 times 5. I don't know why I wrote 4 times 5.